Look at example 1. This is where the product rule will come in handy, because if I look at those two functions, those two expressions, those two parentheses, it's going to be a lot of multiplying that we're going to have to do. Now, if you want to go ahead and multiply it all out, you do what you have to, you do what you can do, but let me show you how using the product rule will help you. So if I call this first parentheses f of x, this is going to be my f of x. And so then this second parentheses is g of x. And so what I have is I have these two functions, f of x and g of x, being multiplied. So that's how I know I can use the product rule. All right, so I'll look at each one separately. Let's look at the first function. The first function, and I'll just go ahead and put first, we know is f of x, which we said was x squared plus x plus 1, the very first parenthesis. So then if I take the derivative of that, f prime of x, using the product, the power rule, x squared, the derivative of that, I bring down the 2, that's 2x, and then I subtract 1 from the old exponent. 2 minus 1 is 1, so I don't have to write the 1, because when I don't see it, once again, that means it's understood to be 1. Plus, this x, like we said, if I don't see an exponent, is understood to be a 1. Bring down the 1, that's 1x. We do 1 minus 1, so that's to the 0. But I know that x to the 0 power is understood to be 1. Remember that. Plus the derivative of a constant 1, we know the derivative of any constant is 0. So if I simplify that, that's going to be 2x plus 1. So that's f prime of x. So that's my first one. Second one is the g of x. G of x equals x squared plus 2. And if you do these problems just the way that I'm doing it, if you go through these steps, you'll never get it wrong. So then g prime of x, I'm going to use the power rule. X squared, we've already took the derivative of x squared over here. Remember, that's 2x. Then plus the derivative of 2, that's a constant. So the derivative of 2, of course, is 0, but I know if I put plus 0, it's just like putting 2x. So now that I have it set up to where I found a derivative of each one separately, I go through, I know that my h prime of x, because that's what I was looking for, right? The derivative of this function here in example 1, I'm going to use the product rule. It's equal to, remember we said we cross multiply, f of x times g prime of x. So that's going to be x squared in parentheses x squared plus x plus 1, and then times 2x, because that was g prime of x. So that's the first part, plus g times f prime of x, meaning I'm cross multiplying these. G of x times f prime of x. So that's plus g of x is x squared plus 2, like so. And f prime of x is 2x plus 1. So if I simplify that by multiplying it through, I'll get 2x times everything in this first parentheses. That's 2x to the fourth. I'm sorry, 2x to the third. My bad. That's an x, that's 2 x's. Plus 2x squared plus 2x. That's 2x being multiplied to everything right there. Then, I know I'm going to multiply these two binomials. So I'm doing x squared times 2x. It's going to give me 2x to the third power. So let me just go ahead and, while I'm multiplying, group my like terms. We're multiplying these binomials. I'm doing the x squared to the 2x. Now the x squared to the 1. That's going to be 1x squared. So let me put that under the x squared term. Now I'm going to do the 2 to everything in that parentheses. 2 times 2x, that's 4x. Plus 2 times 1 is 2. Okay. So if I combine like terms, 2x cubed, that's 4x cubed. 2x squared, that's 1x squared, is 3x squared. 2x plus 4x, that's 6x. Then bring down the plus 2. And that's my derivative.